Video lesson 11.2, the midpoint formula. So when we were talking about distance formula yesterday, we got the understanding of how long a line segment can be. Here, the midpoint formula, we're going to utilize a lot of times in conjunction with it, but we're looking for the middle or the center of the line segment itself. In this first example, it says that line segment CD is bisected by AB. And the question says if M is the midpoint of which of the two segments. So again, you got to be careful on the information and the description because it says that CD bisects AB. So CD is cutting AB in half. So in this example, all right, M is the midpoint of AB. So in this case, it's line segment AB. And that's because CD is bisecting AB into two congruent pieces. All right. For part B here, which two segments must have the same length? Well, now that we know that M is in fact a midpoint, it now tells us that AM and MB must be congruent to each other. If M is the midpoint, it breaks something up into two equal pieces. So therefore, we can say formally that AM is congruent to MB or BM, whichever way you want to do it. All right. And again, that's a lot of stuff that we had talked about earlier in the year when dealing with, sometimes we dealt with it in proofs, the midpoint, definition of midpoint, things like that. So we're going to utilize that often in the near future with those proofs that I was referring to, but the coordinate proofs where you're asked to prove it like mathematically using a graph or points or information. So here on this example 2, it says that MN contains point P. Use the distance formula to prove that P is in fact the midpoint of MN. So we can show that the distance between MP and PM is in fact the same thing. So let's do that now. Let's take the distance of MN and split it up into MP, find that distance, and then we'll also do the same thing for PN and find that distance. All right, so the first one, we're using M and P. So we've got the X terms. Difference in the X's squared plus the difference in the Y's squared. Remember, again, the order doesn't matter as long as you do it from the same point each time. So I've got -8 squared plus -6 squared. That's going to get me 64 plus 36 square root of 100. Nice simple one, just 10. So again, if P is in fact the midpoint, that means that when we do this, PM should be the same thing. So let's find that out. So square root X difference in the X's squared plus the difference in the Y squared. So we've got -8 squared plus -6 squared. As we do this, we're seeing we're getting the same values, which means I get the same square root and the same resulting value. So as you can see, we do in fact have two identical values. We've got 10 for MP and NP is also 10, therefore confirming that P is in fact the midpoint. From there, so I could do that, that's wonderful, but we don't have to do that every time. Distance formula, it's not terrible, but it can be a little lengthy at times. We do have an alternate means to that. If you look at example 3, it gives you, using the same picture up here as the graph, M and N from exercise 2. Find the average of their X values and find the average of their Y's. So what they're asking for here is, what's the change from here from here to here. This is my x change, right? From there. So all the way, this is all the way to n actually. So all the way to here. All right, that would be my x change. And it also wants to know what's my y change. What's all of that? All right, so the average of that. So we're going to do the x. We'll do the x's first. All right, what do we have here? We've got what's the average? So I'm looking for the total, right there. So we've got 2 plus 18, right? And then that would be divided by 2. So 18 divided by 2. That gets me 20 divided by 2, which is 10. All right, let's do that same thing for the y's, right? So that's 3 and 15, right? AKA all of that. 3 plus 15 divided by 2. Well, that's 18 divided by 2, which is 9. If you notice, right, if I make that into a coordinate, that would be 10, 9. That is, in fact, P. All right, so the average of the x values, the average of the y values is a fancy way of saying, right, what's the overall change, average change here, right, which would be this part, and the overall change happening here, average change there, would be that part. And if I was to bring them together, that gets me my midpoint. All right, so we have a nice little formula that'll help us organize that and remember that process. Here it is on the back page. All right, so this is your midpoint formula. A lot of times when I'm doing it, you'll see me I'll write MP for midpoint. So that's the formula. It's just simply an average of your x's and average of your y's, and then put it into a coordinate form. The key though is you do have to make sure that you write it as a coordinate. All right, so let's try some of these. For each set, find the coordinate of the midpoint and the segment, joining the two together. So let's do this one here. So once again, we've got the average of our x's. Got -5 plus 9 divided by 2. Let me just label this the x's. All right, so that's going to equal 4 over 2, which is 2. Let's do the same thing for our y's. All right, we've got 7 and 15. Again, average, add them up, divide by 2. 4. All right, so we got here. So 7, that's at 22 over 2, which is 11. So now we know that with this part and this part, I now have a midpoint that equals 2, 11. That's my coordinate. That's the location of the point directly in the middle of both -5, 7 and 9, 15. All right, take an opportunity, pause the video, try B, see what you get. All right, and here's the answer. So we've got the x's and the average of the x's, average of the y's. Our midpoint comes out to -1.5, 8, or if you want to write as the fraction, -3/2, 8. Again, either one doesn't matter, whichever version you like here. As long as the decimal is a nice decimal like that, it's fine. If it was something like a third, then you have to write it in fractional form. All right. Next example, example number 5. So in this case, just like we did before, it allows us to kind of utilize things and find other things when dealing with the coordinate side of stuff. So let's see if we can find the midpoint on the graph. Again, I can use the midpoint formula, right? For here, because we're on the graph paper, we can also cheat and check that we made it correctly. But let's do the midpoint formula first, and then I'll show you how to verify that you've done it correctly. So we've got the midpoint in this case m, right, is going to equal, it's going to be -1 plus 3 divided by 2, right, and then -3 plus 7 divided by 2, right? That would be quote unquote our coordinate. All right, let's simplify that. -1 plus 3 is just going to be 2 over 2, and this is going to be -3. Let's just make this a little clearer. This should be a -3 plus 7, so that's 4 over 2. And if I simplify that even further, I can get 1 comma 2 as my point. So 1 comma 2 puts me right here for m. So again, I told you can kind of cheat a little bit. The change from a to m has to be exactly the same from here. So if I go up, and I can count, so I got 1, 2, 3, 4, 5 over 2. That I have to have the same thing. So if I go up 5, 1, 2, 3, 4, 5 over 2, I do get, in fact, get to b. So you can kind of visually check on the graph that you have the midpoint is correct. The same has to be exactly the same for both of them. Can't do it 2, 3, 4 times like you sometimes do with the slope to find other points. It has to be exactly 2 to get there. All right, so m is correct. So that's our midpoint. What's the slope between AB? This is what we were just talking about, right? From here. So it's up 5 over 2 for this part, right? The overall slope, right? Overall is what they're saying. So again, we did it individually. You could have also said that the overall change, that was 10 over 4, right? 10 over 4, which obviously simplifies to 5 over 2. So that part is helpful. And it says draw a perpendicular bisector of AB and state its equation. So now they want, this one's a little bit more advanced, but they specifically want a perpendicular bisector. So we know that that is a line that intersects AB at 90 degrees, because that's perpendicular, 90 degrees. And bisector means in half, right? AKA at midpoint. So we know that we want this line to intersect at the midpoint and form a 90-degree angle. So we've got a little work to do here. Nothing crazy. We already know the midpoint. We know it has to cross it at M. So the 90-degree part. If I have, in order for a line to be perpendicular, as we discussed earlier on in the year, the slope will be an opposite reciprocal. So perpendicular slopes are opposite reciprocals. Therefore, whatever your slope is, so in this example, we've got 5 over 2. So if the slope of something is 5 over 2, in this case AB, the perpendicular slope is going to equal, I'm going to take that fraction, I'm going to flip it upside down, like so, and whatever it is, I'm going to do the opposite sign. So this is a positive slope, this is going to become a negative slope, okay? Again, it doesn't matter who you give the negative sign to, the top or the bottom. As long as you only give it to one of them, then you're good. If you give it to both, then you're still a positive value, so that doesn't work. All right, so now I know that my new perpendicular bisector line is going to have a slope of -2, 5, right? So if I was to go over here on the graph paper, I could now do that. I can now go down to right 5, 1, 2, 3, 4, 5, put a point. I always like to do at least 3 points to make sure I didn't make any mistakes. So if I do the same thing in the other direction, up to left 5, 1, 2, 3, 4, 5, right? That gives me a line there, right? And let's see if I can... Oh, don't have it. So we're just going to draw a freehand line here. You guys can use a straight edge. Make a much better line than I just did, right? But that would be my line, and we would know that that must be perpendicular, right, from there. So that's the key part. Now the equation portion, and we're going to get more into this a little later on, but at this point, you guys should be comfortable using y equals mx plus b, right? So you can determine exactly where it is across the y-axis. That would be your b, right? y-intercept, and m would be your slope. All right. I'm going to show you guys the point slope formula, right, which is y minus y1 is equal to m times x minus x1, and this is referred to as point, let me do it over here, it's going to run off the screen, point slope formula. All right, this one here to me is a much better formula to be using on a norm, because all I have to have here is a single point and the slope. So the x1, y1 represents a point on the line, and m is the slope. So a lot of times we don't know where it may cross the y-intercept, or maybe it doesn't cross nicely, and that's very often the truth, but I can always kind of find a nice point a lot of times. So it makes it a lot easier to do. So I'm just going to utilize this point over here. This was this one here. That's a point on there. We could use the midpoint. We could use this point. Any one of these three would work. Actually, let's use the midpoint since we already did that. So I'm going to use the 1, 2. So we're going to have y minus 2 is equal to the slope, which we already have here. So that's negative 2 over 5. Times x minus x1, which I'll go back up to my midpoint and use the 1. And this is the equation of our line. You can simplify it. If maybe the negatives are positive, you have to make that. That's fine. This is done. You're finished here. As long as you plug that in, you're finished. The nice part with that is that's all you need, because that is the equation of a line. If you needed to make it into y equals mx plus b, we could distribute the negative 2/5. We could add the 2 over. That would get you into the form of y equals mx plus b. At this stage, honestly, I don't mind either version. Whichever way you want to do it is fine with me. I like this one. And in the future, we're going to do some other things that the point slope formula definitely makes things a lot easier and a lot faster. So I would start, practicing and utilizing the point slope to make things easier for yourselves. But in the grand scheme of it, honestly, either one is fine. All right, hope that video lesson helped you guys out on finding the midpoint and using the midpoint formula. Take the opportunity to, pause the video, go back, check it over, and finish your notes and work on practice problems with these.